Hi everyone. So in this video, we'll continue our series from counting numbers to quantum computing. So this will be the fourth video of the series. Previously, I've covered the number system, and then we have covered multiplication and as a language of earth, the language of math, how we write things in a math, right? So so we are thinking from like caveman perspective, how numbers might have been invented, right? And I'm digging up little history nowadays to learn about Babylonian math, Sumerians, how Sumerians used to have math. And once you understood the past, you can predict a lot of futures, or even you can guess what would the reason for certain things, what they have done, right? What are the steps we took, why something failed and we came up with new things, right? There are so many new stuff we have in math. So we'll start with fractions. So if you have a problem like there are 30 sticks and there are 10 kids, how many sticks that each kid will get equally, right? So we have 30 candies that we can see over here, and then probably means we want to distribute it equally to the kids. Like it's kind of division, right? Division is the first time I'm talking about division, and division is basically distributing certain number of things equally to the number of kids or whatever you have, right? How we can do it? We can represent 30 sticks like this, and then we have 10 kids, so each will get one over here equally, right? So this way we can count that 3 sticks we got, for each kids will get 3 sticks at least, right? And this was a very easy things to do because we have already grouped, that we have learned from our system, that we always group things from the multiple of tens, right? We call it ones, tens, hundreds, right? So 36 is group of 3 tens, right? And we already know about what grouping it, how grouping help us to divide, add, subtract, right? Same way it also helps in division as well, right? So if we have grouped this way and this 36 kind of well matched, and we could each one by one row, each group we can distribute, and there was 10 kids, and we can see that 3 sticks will be. This was pretty simple, right? This was a simple division. And also division was required back then because if you're a caveman, you hunted a meat or something, and now you have to equally distribute amongst your like cave members or your friends and family, right? And if you don't do it in the right way, there would be always a fight or something like this. So that was always a problem, right? And so division was very essential. Even kids fight if you don't distribute things equally to them or something like this. So that happens usually. So it was very important. But simple, these kind of divisions were very easy. We'll see the little difficult ones. And just a second. Yeah. And there is something called number line I want to discuss. Uh, Number line is where we distribute our numbers like this: 0, 1, 2, 3, like this. And just like we learnt in number system while adding and subtracting, that we group something like 10. If I have something and if it is 10, I can group them and make it as a 1/10. Right? That tens can becomes hundreds. Right? If you don't know that, you can check out our first video of the series where we have talked about. Same way, while division, the previous example was perfect division, but we can same way, just like we grouped something of tens, same way we can divide equally the parts of 0 to 1, right? If something, if I have a number is 1 or 2 or 3 or 4, I can subdivide them into 10 parts like this. So between 0 and 1, 1 is basically one few thing, and I can chop them in a small section and I can divide them as 10. This is a very natural things to do because our number system is based on base 10, right? If you remember, there so many number system I talked about, number system with base 2, 3, 4, 12. 12 was the best one. It has like very, like it has some features, right, which we already discussed. But in this case, we stick with 10. Same way we can, the way we can group thing together as the numbers of 10, same way we can divide as well the numbers of 10. So we divided 0 to 1 by 10 equal parts. Same way we can do from 1 to 2. Like 2 could be divided into 20 parts. Like if I have 2 sticks or something, I can probably divide them in equal chunks of 20. Like I slice them small pieces. Same with 3, I can do divide them 30 parts like this. And we call them certain, like if it is the first values, first division, we call it 1 by 10. And second, we call 2 by 10 or something like this. This carries on, right? Once you reach 1, then we call 1 plus 1 by 10. Now 1 is already there, now you adding little more fraction to it, 1 by 10. So this is how we represent number in fraction form, right? If you are not able to make sense, you will soon make sense by our next example. Let's say we have previous exam we had 30, this one we have 31 sticks and 10 kids. And now how many sticks each kid will get, right? What we will do in this situation? So basically we can represent 31 sticks as a group of tens, just like it. These could be called tens, first tens, second tens, third tens, and then we left with one stick and we have 10 kids, right? So how we can equally distribute that? We can first distribute first group, right? We have a number line over here. So if you first distribute these ones, right? So what that means, each kid will get one stick, right? So that one over here is represented. So each kid at least will get one stick, that we can see over here. Then again we'll get another stick, then again. So you can see 3 sticks. So the goal is to find how many sticks each kid will get. So at least 3 we will get, right? Now we are left with one stick, and one way is to do is we can give this one stick to this kid, then this kid will have 4 sticks, but it will not be equal. These others will be have 3, and this is not right. So we have learned about fraction. We can split this thing into equal 10 portions, so that we can each give them little chunk, right? So that we will do. We'll chunk them into small pieces, and then we can distribute these small chunks. So now each kid will get 3 and this little chunk, right? So that we call it 3 sticks over here, and this little chunk as 1 by 10 sticks. So that is basically the total sticks we have. And probably on the number line we can see, actually I missed that one. Let me pass forward. Yeah, so over here we can have second answer, and this little chunk is 1 by 10, which I can add over here, right? This small piece, because it was distributed equally as 110. So our answer you can see on the number line as well, 3 1 by 10, right? There are different forms of fraction. These ones are called mixed fraction. These are called normal fractions, right? You don't have to distribute like you don't have to get distracted with this, but just to let you know. Let's say another example. If we have 16 sticks and 3 kids, how many sticks that each kid will get equally, right? So that same way we can do this one as well. 16 kids we will write as a group of 10s, and then we have extra 6, and we have 3 kids over here. So if you remember, all the rules which we have made was like all the system, like just like in library we pre-organize things so that taking out book, placing them, searching within the books becomes easier. Same way we pre-organized our numbers into 1, 10s, 100, so that addition and subtraction could be done. Basically we group them into form of tens, right? Tens, hundreds and thousands like this. Same way our 16 was grouped as 10 and 6. But this time we don't want to distribute equally to 10 kids, 3 kids, right? So now, and also we have talked about number system with base 10, where the repetition come after 3, right? If base 2, base 3, base 12, the repetition will come, like the grouping will done after whatever the base system we are using, right? If it is 12, then groups will be of 12 thing, right? Same way. So now here, although we have sticked with 10, base 10 number system, Now we want to leverage the idea of other number system. This is a very not right way. Still, I am against it, but this is the way people at that time figure out. Although we are in the base 10 system, we can dwell upon the other properties of this. So now this time I wanted to divide between 10. So it will make more sense for me to group them into 3 so that I could do it. Although our number system, the agreement we made was on base 10, somehow we are trying to sneak in or trying to break that agreement and try to make the instead of groups of 10, because the requirement is to divide it between 3. It will make more sense, or it will become more easier if I have my numbers grouped into form of 3, right? So natural order is 10, but for this example we need to group them into 3. So that we will do probably, and we have a number line that I will explain you. Just let me finish this one. So we have grouped them in scene, and still, so first kid will get 1, that we can see over here, then third, and fourth, and fifth, right? And then one left one, we can split them in 3, just like we did in the previous example, and we did this. So usually what we do when we split something between 0 and 1, we do the splitting 10, because that is the number system we chose, base 10, right? But for this example, we are trying to sneak into other number system. We are trying to mold our numbers into another number system, basically base 3. So same way, instead of dividing into 10 equal parts, we just divide it into 3 equal parts, right? So first piece we can call 1 by 3, because it is one part of the whole 3 groups, right? And this is 2 by 3, and this becomes 1, and then again 1 by 3, and something like this. So first distribution when did the 1 came over here. So total of whole sticks, it will be 5, and then the small chunk over here, right? So the small chunk over here, that will be probably 1 by 3, right? It could be equally divided into 3 parts, and the small part is over here. So my solution will be, each kid will get 5 1 by 3 sticks, right? So this way we are kind of cheated a bit, because we agreed to have everything on the basis of 10. And in the previous example, as you have seen, we divided this sticks into like the pieces of 10, which made perfect sense. That was the very much agreement we made. But over here, just to leverage this idea of other bases, we can do this thing, right? So whatever the requirement, we can tap into that base and just use it on our number system. So this way we were using it, right? And it really made sense, right? If I just split something into 3, I only need 3 divisions, not 10 or any other number, right? So I hope it makes sense to you. Fraction equivalence, what that means is basically, if you see a fraction like 2 by 3, right, there will be another fraction which also represent the same thing, right? There is no question over here which we are trying to solve. I'm just giving you a statement, and this will be very useful when we actually do fraction additions, right? So if I have to represent 2 by 3, first we will have a number line 0. These are my natural number lines, 0 1 2, right? Like this number lines are nothing, just to represent a number in an orderly way, right? And this. So because now we are dealing with fraction with base 3, probably my divisions will be only 3, right? Because fraction we are dealing with base is base 3, right? So you can divide 0 and 1 into equal parts, and this will become 1 by 3, 2 by 3, right? Then 1 1 by 3, 1 2 by 3, right? And I'm saying that 8 by 12 will be also equal. So first of all, we have to make a number line for it, right? For fractions of base 12. So instead of 10, we'll divide with 12 divisions between 0 and 1, right? Just more 12 small pieces. And you can see when I just map this 2 by 3, like this, basically this is the value. Like if I say 2 by 3 of something, this will be the length, right? That much is the 2 by 3. So this is the 2 by 3, and same length if I have to plot it on the fraction of 12 base, you can see that the same length comes with 8 by 12. So this length, like somewhere if this length is, I have to measure this length in a problem, just forget about this number line. If this much size of stick I see somewhere, and I have to find the length of this, I will see the mapping, right? I'll see the mapping, go here and see, okay, this probably on the base 3, it's 2 by 3. On base 12 of fraction, it is 8 by 12. So we can say that the same length could be represented by multiple fractions. It could be 2 by 3, it could be 8 by 12, it could be 16 by 24, it could be anything, right? So you can check different number lines and split them, like, and see different fractions of between 0 and 1, and you can map it and see where this exists. Same we can try for 3 by 4, right? 3 by 4 again, this is a fraction of base 4, right? So natural order is to have base 10, right? That was the agreement we made initially. But with base 4, this is saying that the numbers between 0 and 4 will be divided into 4 equal parts, right? Or between 1 to 4, that will also 4. Between 2 to 3, that will also 4 parts. So here you can see it becomes 1/4, 2/4, 3/4, and then become 1. So 4 equal parts you can see over here as well. And same way for 9 by 12, for fraction with base 12, you have to make 12 equal parts over here that you can see over here, right? And same when I have to map this 3 by 4, right? 3 by 4. Basically this, when I say basically, so this 0 to 1 is 4, right? What that means is this 4 means you have 4 equal divisions. One division is this, two division is 3. Like you can think lot, it's a tray, like a tray of four compartments, and 3 are filled. So you can see 3 being filled over here, right? And 1 is left, right? So that actually makes sense if you see in the fraction term. Like we have 4 compartments, 3 has to be filled. That is over here, right? And if I just pick this same length, right? This same length and put it on the fraction with base 12, that will be some around 9 by 12. So 3 by 4 can be also, this stick length could also be called 3 by 4 and 9 by 4 as well. And 9 by 4, it makes sense because now we can see we have 12 compartments and 9 is filled. So 9, you can see the first 9s are being 3 are left. So 9 by 12, it also makes sense, right? It thus must be in the previous slide as well. So on the previous slide, as we see 2 by 3, right? Which means that 0 and 1 are divided into 3 parts, and 2 has been filled. So this 2 will be get filled and this third will be empty. So 2 by 3 also makes sense, right? So this is whole thing, 0 to 1, there are equal 3 parts, which means this part, and 2 is filled, right? Same way 8 is being filled over here, 4s are left, like total compartment here 12 and 8 is being filled over here. So now we have to do addition, right? Let's say we have something, 2 sticks, and that is 2 by 3 plus again another stick with 2 by 3 by 4, right? So we have those 2 fractions like this, and if you have to add, what we can do. So first we can add this 2 part, whole number part. Just keep the fractions out. We can keep the fraction out and just add the whole numbers. That becomes 4. And then we just solve this one, and whatever the answer comes, we will add back to 4, and that will be our answer, right? So just like simple addition, we have a fraction addition, which also has this whole number addition that we have already learned in the first video. So over here, first I'll draw a number line for fractions with base 3, which means this basically that there are numbers 0, 1, 2, 3, 4, and between 0 and 1 there will be subdivisions where it will divide in equally. Between 0 and 1 it will be divided into 3 equal parts. Again from 1 into 2 it will be divided into 3 parts, or 2 in furthermore in the list you can go 2 by 3, it will also be like this, right? And it says 3 compartments, first 3 initial compartment, 2 will be filled. So over here you can see from 0 to 1 there are 3 compartments, right? 3 empty slots, and 2 is being filled. That means 2 by 3, right? So 2 is filled over here, so you can see this becomes 2 by 3. And this is the same size. If I have to draw same size, and so this is the length over here. You can think as 2 sticks, right? One stick is a 1 by 3 length, another stick is 1 by 3 length, and that stick has to be added by 3 by 4. So again, I'll draw a number line to represent how 3 by 4 looks like if it is a stick or a candy. So candy of 2 by 3 will look something like this. 2 candies like this of this certain length, right? And let's have to add with 3 by 4. And how 3 by 4 looks? Again, 3 by 4 means fraction with base 4. So again, it will be like 0 and 1 divided into 4 equal compartments, and 3 will be filled. So over here, this is, you can think, first stick or candy or something which looks something like this, and I want to add it. And basic rule of addition we learned in our second video, math as a language, that to add something they has to be of same kind. Apple can be only added with another kind of apple, like they has to be, look, if there is a 2 apple and there is a 3 apple, they can be added together. But if there are oranges, they cannot be added together because they are of different kinds. Applying that same rule, if I have a stick, like when we were grouping numbers into 1, 10s, 100, the sticks were of same size. That's why we could group them. We call them, they are same, right? And also to make addition, they has to be same. But if you see 2 by 3 sticks, think like these are sticks, right? 2 by 3 sticks, their length, they are basically 2 of them, and their length is quite bigger and doesn't matches with these sticks. These sticks are smaller. This one is small, this one is small, this one is small. They are not equally. So these two can be added together. So they are already added together. We call them 2 by 3. These cannot be added, right? First of all, they cannot be added. Even if we force it, how we can force it? We can just, okay, maybe we can add and get answer on the base 3 only, right? There could be many solutions. Any addition or something, addition or subtraction we can do on base 2 as well, base 3 as well, base 4 as well, base 5 as well. Same way we can do addition on the base 3 fraction only. So what I'll do, I'll push this number over here, try to add it. First of all, it will not add because their sizes are not, it doesn't make sense to add, but still we can do that. So that we'll see in the next animation. So what we did over here, we brought the sticks over here, and so my answer would be, if we add this thing, my solution will be somewhat, the answer will be 1 by 1 by 3 and some more number over here. Now if it was perfectly over here, then the answer would be 1. The addition of this 2 by 3 and 3 by 4 will be 1, 2 by 3. But it's not at this point and not at this point, nor either. It's somewhere outside middle. But there doesn't exist any number. In a fraction world, there doesn't exist any number. This is the limitation of fraction. There doesn't limit. If I have to guess what their solution would be, it will be probably more than 1 and 1 by 3, right? One stick and then little 1 by third part, something then more. Probably somewhere around some number over here, right? More than this probably, but we don't know the exact solution. We don't know this, what we call to this extra part, right? So that is the limitation. So we cannot add this thing like this, right? We can try on this one as well, on the base of 4, try to add in the base 4. Let's say maybe it is possible on the 4 as well, right? Maybe my answer will be, so if we are able to add on fraction base 3, then the solution will be base 3, and we can do the same thing for base 4 as well. So over here 3 by 4 is represented over here, basically because the 4 compartments are there, 3 are filled. We can bring this length over here, try to add and try to note the total length that we can do. So we'll see where it gets placed. So if you bring this one over here, it comes over here 1 by 4. So already know that it is quite, if you remember the previous answer was somewhere around this thing. So this one tells, okay, it is more than 1 by 4, but somewhere around. If it has reached over here exactly, then I would have said, okay, the answer is 1 stick or 1 candy and then another 2 by 4. But it is sliced middleware and there is no number over here representing that, right? So this will not, first of all, these sizes are different, so we cannot add them. It's like adding apple and oranges. Second, there is no number representing that length over here, right? So the solution is somehow we can find the equivalent. Just remember, if in the previous slide we learned uh, that a fraction could have an equivalent fraction representing the same length, right? 2 by 3 or something could represent by 8 by 12 or something like this. Then 3 by 4 was something, it was 9 by 12 or something like that. Same way we will translate this fraction. We can find this equivalent. Same fraction can we represent with another base instead of 3, 4, 5, 6, 11, 12, 13, 14, whatever number. So that we can try. Probably if you remember from the previous few seconds, we actually converted 2 by 3 into the base 12, and that actually had some value number which actually existed over here. If you see over here, we can bring this 0 to 2 by 3, that is equivalent to 8 by 12, right? Same length, and in this condition, I don't have this somewhere answer over here in the middle of where there is no dash and there is no number was exchanged. When we have when we divide a number between 0 to 1 or 1 to 2 between 12 parts, there are so many options, and because of that, this 2 by 3 can equally fit over here, and it could call 8 by 12. And we can also bring this 3 by 4, and we can try to add, and if it reaches perfectly somewhere at this point, and we have a number for it, 1 5 by 12. So when we add those two numbers, it becomes 1 5 by 12. No, not 1 by 3, not 1 by 4, right? 1 5 by 12. This is the exact solution for our addition. So this part, this parenthesis we solve, I'll get 1 5 by 12. So 4 is already there, right? We can add this 4 as 1, it will become 5, and then 5 by 12. So you can see the addition over here. The equivalent for this fraction was 8 by 12, and this became 9 by 12. And we add it from here, it becomes 1 5 by 12, and we add them, that becomes 5 plus 5 by 12. So the addition of these two fractions become 5 by 12, right? So how we do addition, if you are lucky sometime, like we could have found our solution base 3 only, right? Basically the first number 2 by 3, if you are lucky enough. Maybe you're second lucky enough, we might have find on 3 in the fourth basis of fraction. But somehow in this case we found in 12. But there are examples where you will be lucky and then you find it, right? And problem with that, this is not new thing. I have been already taught fraction in my way, but that time I was taught the shortcuts. The answer was given, you need to find the LCM of this and multiply. There are a bunch of rules which didn't make sense to me back then as a kid. But people imposed the rules on me somehow because I was afraid of getting hit by my parents or something, like they forced me to learn there was a reward and punishment system, right? And I had to go to school, like to go on grades, and that way they forced me to like understand the rules and don't question whatever. Like it didn't make a lot of sense to me. But when we see fraction in the number line, how it is a number. Basically, fractions are numbers which are less than the whole numbers 1, 2, 3. Between the numbers between 0 and 1, 2 or 3 something. And there could be multiple way to denote them. It could be in the base 3 form, which is a cheating. This is a cheating way of doing things. We have decided a central contract that we will group things in form of 10 because we chose the base 10 is our number system, Indian Arabic number system. But somehow we are rebelling. First example we did where we divided by the pieces, small pieces, 1/10, right? That was actually the right way to do, but over here fraction is kind of leveraging the basis of other number system, right? 3, 4, 5, whatever you feel like, and then you divide them. So it might be little confusing, right? But I think for me, if I do this way and I know the reason and see form, it made more sense to me than remembering bunch of methods like finding LCM, then multiplying this and then doing extraction bullshit and whatever not. Okay, so fraction, and now let's say if I have to do the same thing. So fractions seemed little complex, and then we were also kind of cheating between the bases, right? The numbers bases. you're dwelling into base 3, 4, 5 something. The people came up with another method. Uh, we call it decimal. Fractions were not that really good, right? It looked little complex, but there was simpler way called decimals, and we were not breaking our central contract of number 10 or multiples of 10, right? In this thing, we'll break things smaller chunks into tens only, right? Decimals are the solution where we don't break our central contract. We keep our best 10 as our single base rule, and we follow that. So that you can see over here. 2 by 3, it's over here in the 3 fraction. 3 by 4 is over here. So in decimal, instead of dividing, like even though the fraction is 2 by 3, we're dividing the between numbers between 0 and 3 equal parts, we will still do it tens, right? And if you just look back, the length of this 2 by 3, right? We fix this length, right? We know that now 2 by 3 looks this long. And the same long, just like we converted in the previous example into 12, same will convert into 1 by 10, right? And this length will be fixed. So this length will become 1 by 10, somewhere around 6 by 10 and 7. Still, this is not. Because only equivalent fraction we found for 2 by 3 was the base 12, right? But we are just doing 10 because we decided we're going to come up with a new method. And in this method, still there doesn't exist any number, right? And this is middle somewhere, but still it will make some sense once you are staying with me in this video. So it's somewhere in the middle, around 6 by 10 and 7 by. And now instead of writing fraction, I could write with a small point, a period or dot kind of thing, to represent 1 by 10 as 0.1. For a small thing, 0.1, 0.3, and same I can do over here, right? This number became somewhere 0.78, somewhere over here. And this is illogical totally, because there doesn't exist a number for representing this part and this part. If this blue line was over here 0.6, or then it was a true number, but it doesn't match it over here. But when we add, actually, so property of one example we see in the previous one, that fractions, when we were representing number 2 by 3, it came somewhere in the middle between two fractions, and there was no middle value. That length doesn't has a number for it. But in decimal, I can subtract like chunk, like I made a chunk because I wanted to divide, and that chunk can split again into multiple chunks, and that again small chunk can split. So decimal gives us that power, the placing value. So whatever more chunks we get at point, we can increase the number. That time we will show you in the example. So this time we can bring this thing and it goes somewhere around 1.4. Still, this is not a perfect example, it's more like fraction. We don't have any number for this little edge extra. Same way we don't have this thing. But in fraction, I could subdivide this for 1.4 and 5. And this subdivision looks something like this, 1.4, 1.1, something like this. Let me go back. Yeah. Still doesn't make sense. There is no number for this point. There is no number for this point in decimal form. But uh, when we add over here, still doesn't have a number for it. Even when we add this over here, still doesn't. Till this now it is more like fractions only. We don't have number for this little point. But decimal, we can subdivide this 1 by 4 into another fractions of 10. So now 1.4 and 1.5 can be subdivided into multiple tens. Small chunks that we call them 1.41, 1.42, 1.3, and we know this extra, this is a little part that could become 1 unit, right? So our solution will become not 1 by 4, 1.41. basically a whole one candy or one stick, then the small four part of it, then inside that four part one extra single unit, right? So this becomes our decimal. So in decimal this will be 4 is already there, 1.45 like this 4 1 so whole numbers we can, anything after point like this 4 1 is not the whole number. Whole number is the on the left side. So this one is the whole number. So we can add with another whole number that will become 5. The answer will be 5.41. Right? In decimal it will become 5.41. Lot of time people from the past like avoided fraction. They developed solutions like inches, sorry, a foot divided into uh, sorry, inches. Inches are basically 1/12 of a foot, or a quarter. Quarter is 1/4, right? They came up with different kind of units or something to just avoid fraction. Even they wanted Sumerians and Babylonians have, instead of base 10 they were using 60, because 60 has more divisible number, just like 12 in a dozen, right? Dozen is kind of unit, because if you use 12 or something, it could be easily divided by 2, 3, 4, 6, right? And 12 even, right? But if you pick numbers like this, it will only divisible by 2 and 5, right? Even if you see the circle, uh, pi is 360 or something like this, right? Time is 60. Why? Because they wanted to avoid fraction at all. There was no fraction, and people has to manage fraction using, like, use fraction as little as possible, because fraction didn't existed back then. So they came up with this different kind of number system: 60 number system, 12 number system with base 60, 12. Then we have different unit. 1/4 was called 1/4. 1/12 of a foot was called inch. So these were like workarounds were there before the fractions were invented. And we reached a point that we need to have fraction, otherwise there was no workarounds over there, right? And then we came up with fraction at that time. Fractions look little complicated, but it has its certain advantage, which we'll probably discuss in next few slides. But it kind of do cheating. Like, we signed a central contract of using grouping of tens. That was because we chose best 10 number system with base 10. Somehow we were dwelling into another basis, just to get our answer. That might have made kids a little complex. Like, hey, we decided with the base 10, why you're like subdividing into now 3 4 or something. So that I don't like the idea. That's why fractions are not for my life. Right now I'm engineer. I am a quantum engineer. I don't use fraction that much. I'm not seen it. We saw a lot of differential equations and these all things. But if fractions were not there, it won't have bothered me that much. But we'll see what are advantages of fraction in decimals. But we can simply think that decimals are much easier to understand. It could subdivide itself, so that we'll have a lot of numbers to play with. One of the comparisons which will, if I ask, like, which is greater, 3/5 and 4/5, then you have to draw the number line and see which one is bigger, right? It is a little more work or something. But if you represent the same number in decimal, it will look 0.6 and 5.7. And now we can clearly say that, okay, this is not greater, right? Yeah. Probably, okay, this is sign. If I haven't told you this sign about greater and less than sign, which means which is bigger or smaller. You can probably say that this is incorrect, because 0.6 is obviously greater. But in this decimal form, it's so much easier to recognize than the fraction form. That's why decimal made quite easier, and this is one of the advantages. But still, fraction has some. But still, I'm on the more on the decimal side. But yesterday I was having a conversation with my friend. He was on more on the fraction side. So I was telling the pros and cons. And only thing which I don't like, that they're in the central contract of grouping or like divisioning things between tens, right? And this somehow, that's why I'm against it. But still, we'll see what are the pros and cons of fractions. So if fraction, if you have to write 1 by 7, right, it doesn't fully get divided, and this number will, the solution is not limited, it will just repeat itself. It goes 1 by 4 2 8 7, again it will start 1 by 4 7. 1 by 7 is more precise, and this is like less precise, I would say. Same way, if you divide 1 by 3, right, if you try to convert into a decimal form, it will become 0.33333333, something like this, and it will never stop, right? So sometime decimal might be approx, not exact solution. Whenever you're doing some minute calculation, something there, it might affect. But in computer science, we have came with different methods to do that. That is not the part of this video, but still, I would like to say that. Ah. Uh, Addition in a fraction, you see, we can do with number system method, which I described just now, or we can use the previous trick. The problem with our education with math is that our parents or teacher shows the shortcut first, and then they never show the bigger picture, the long picture, right, the long route, and they just want to solve it and just put bunch of rules on the kids. Take LCM, take this thing and do this thing, and they skip the part, the number system, the fraction, the division between the number, which we have just seen, right? And we just there, and that doesn't make sense. Yes, it gives answer, but for me, those, I never understood the rules, why we were taking LCMs and all like this, right? So over here, this method, you see, it is little complex. Adding whole numbers are quite simpler. Fractions over here, you have to convert into LCM. You have to find 1 by 4 equivalence. That, to find equivalence, either you do this timeline thing which I just showed, randomly try different numbers, see which fits, or there is a method shortcut, you can find LCMs to find the equivalence of 1 by 4, which is 5 by 20, and equivalence of 1 by 5 is 420, and then you add them. But same number, if you have to add in decimal, it becomes very easier. You can check that. I haven't taught you. So idea of these videos is not to show you everything, just to give you this lens, right? This is a red lens which you wear, and everything's look, the piece of paper, the knowledge is same, just the way you look, it becomes different, right? I want to give you that framework or the mindset to look these things, revisit the math back, and just I want to give you that tool of like like going from the beginning, right? Now you can see math in a different light and see things differently, right? So this one, with this fraction way, we can add like this. It's quite simple. This you have might have already learned, or you can watch some other videos or something where they will tell you how to add. But it is very much simpler than just think about removing this. Just add 25 and 20, doing 45, and then you add these dots. So it is much simpler. So some additions are much simpler this way, but there are few additions where the fractions become more sense, right? Which you will see in the next example. Like if I have to, just like I showed you 1 by 3, it just go repeating, right? And doesn't make sense. So I think that was it for today. We have seen fractions was a solution, but it was kind of breaching the central contract which we had. It was not breaching, which is we were taking advantage of different base forms and getting a solution. But there was a point where the number will stick between one answer, like one fraction between, and there is no value between. Fractions are not subdivided, but we came up with a decimal system which could be subdivided into multiple divisions, and then at some point you will find the answer. And decimal doesn't uh, breach the central contract of grouping them in 10 or fractioning them in 10, everything in the multiples of 10, which make a lot of sense, right? Which it looks more natural than the fractions. So that's it. I hope you have understood the fractions well enough right now, right? You don't now you can deduce all the shortcuts which people have taught us, or you might have understood like why we take LCM, why we'll divide, why we multiply, how we add, like how fraction addition makes sense. Now all those things make sense, right? When we see we use bases of all numbers, and then we make like what do you say? Like 4 container. Like if I say 3 by 4, there are 4 spaces and 3 is filled, right? This way you can see fractions in a different light now. I hope that made sense. This is basis for our few hard things which is upcoming way. So next videos will be, I think, on coordinate systems or fractions. I do want to talk about negative numbers, right? Negative numbers are basically, uh, it's like previously there was no negative numbers, like there was no, because negative numbers is kind of imaginary number. I would say it's an imaginary number. So I want to cover it when we teach imaginary numbers, right, in detail. But I can tell you, like, let's say person was in debt. I was in debt. I was a person from past. That time the math was not really invented, and I was somebody gave something and I lost it, right? Somebody gave me two sheeps and I lost it. So now I'm like in debt of minus two sheep. Or somebody gave me money and I lost that money, I spent it and I don't have that money to give back. Then now in debt. So those numbers, debt could be represented minus numbers. Right? So we'll probably make a detailed video when I talked about imaginary numbers. So we'll see that time. So I hope you have subscribed, and so that we can be part of this journey. What I say, rational math. Is this was inspired from, because I was learning a lot of what do we say, evolutionary biology, like how human evolved through, and it did answer my lot of futuristic questions. Learning about past will give you a lot of scope or vision to answer the future problem or fill in the missing blanks, right? And so that way, while reading this now, all the radians, all the units, conversions, right? I use 360 to divide the angles. Why? This all made sense because they were all running away from the fraction. They wanted units where they don't have to do divisibility, or they wanted to pick a number where that could be divided by two in a perfect way, or something like this, right? In this way, if you see fractions, uh, when we convert into decimal, most of them will be occurring decimal. They will never finish. So we'll only take approx or you do round off. Like if I have to do 1 by 3, it goes 0 by 3333. So we are round off to certain number. So with this system, with decimal, only with fraction with base 2 and 5 will completely get divisible and they will have a perfect answer. Like 4 by 10 or something, it will become 0.25 something, and that will end. There is no repetition after it. But if you have picked the number system with base 12, now it will be divisible by 2. So their fractions will be always a perfect, like the decimal will end. Somewhere the answer will be like ending. There will be no approximation or repetition of the number. So it won't repeat by, if we had a fraction, if we have base fraction with base 12, right? That 2 will be divisible, 3 will be divisible, 4 will be divisible, 5 will not, 6 will be divisible. So when we have fraction with base 2, 3, 4, 5, and when we want to convert them into decimal, they will all have a certain answer. There will be no repeating numbers over there. So no approximation required. But we are dealing with, we decided decimals would be the fractions like converted into base 10 only. So there only the solution will, which will we get exact solution will be on 2 and 5, right? Fraction with base 2 and 5. Their decimal will be always like solve. Whenever you have to divide something with 2 and 5, there you will only get exact solution decimal, and most of the number will be like it will go on and on and on. So you have to do round up. I hope I didn't confuse you more enough, right? If you're a kid watching this for first time, you don't have to just rely on this video, but these videos are giving you those lenses to watch math with differently. But you do have to do a lot of hard work, watch other people videos and use the faulty method which our parents start teaching a bunch of rules, right? But those rules will make more sense when you understand this core thing, when you have this red lens to watch things in a different way. I hope I don't bore you so much with this rant, but see in the next one, lot more exciting things are coming. I hope you subscribe, like, comment, or any opinions you have, just write it. Really motivates to do well. So see you in the next one.